So let's go ahead and continue. What I've got here with the literals, that's pretty much, I've pretty much already explained that. Sometimes you can use underscores to make numbers easier to read. You know, quite often in English we use like a comma to separate digits to make it a little easier to read. In Swift, and most programming languages won't allow you to do that, but in Swift, what it will allow you to do is to be able to put an underscore in, to be able to say that, to make it a little easier to read. So for example, these examples here, let's go ahead and look at our compiler. We can you could separate a number like that, and this is just equivalent to 1, 2, 3, 4. And this is mostly for the user, to help them to be able to parse a number easier. The compiler really doesn't care. So if we see here, let's see what gets printed. Yeah, it prints 1, 2, 3, 4, and then it prints out this number. So what happens, the compiler takes this, it then is able to interpret this to what number this represents, and it outputs it like this. Looking at the notes, you can try these if you'd like. You can place an underscore wherever you want. Swift doesn't care. We talked about floats or decimals. Remember that a float has a decimal point in it. So we can do anything like this if we'd like. Any of these. The E5 is equivalent. Think of it as like the 10 times 10 to the 5th power, just a way to represent a value in a more compact form, or it is also equivalent to this value. Negative e, 2e to the negative 4 is equivalent to this or this. So you could write you could write this or this, and it'd be fine. So let's try that. Let me copy this. And these are some things that you should be doing yourself, copying maybe a little bit of this code, playing around with it a little bit. And let's just say, let's print, oops, needs to be lowercase decimal. Let's see what happens. It compiles it, and it outputs this value. So notice there that I said that this was equivalent to this or this. Notice that that's the value that we get. So we could actually write it like this. If you want, let d equal negative 0.3 zeros and then a 2. And let's just print the d afterwards and see if we get the same value. Notice we get exactly the same value here. So you could write it like this, or you could write it like this. It's really up to you which way you want to write it. Now you can't write it like this though, so keep that in mind. You'll have to notice that it's easy to convert from this to that. You just put an E where you have the times 10, and then you just put the negative 4 that's here. So just keep that in mind. You can try for some of these other values as well, if you'd like. Now, with numbers, we usually want to do things with numbers. In my notes here, I have an import foundation before using round, ceiling, and floor. Actually, with the Swift, you'll want to use import glib. There's no foundation. So let me do this. Comment that out and I'll show it to you. Foundation. Click on run, it's going to say it doesn't understand, no module name foundation. So go ahead and get rid of that. And then we can start playing around with some of these values here. Round these values. And I'm going to go ahead and copy all of these here. This is a round is a function that allows us to round to the nearest whole number with whatever. If it's 0.5, it rounds up, but note that negative 0.5 rounds down. So it rounds to the biggest number, if that makes sense. It's a little confusing for negative numbers. Now, if we run this, we're not printing anything, so we should get nothing that's printed. So keep that in mind. Somebody said, well, what's going on? Well, what you got to do is you got to put a print statement around this for it to print out the result. If you do that, it'll print out 3. Actually, it prints out 3.0 because we're rounding it to the nearest number, which is 3.0. This is going to return a float, a number with a decimal point. So actually, my notes are wrong. These should all be like that. So I'm just keep that in mind. So a couple of things that we could do here is let's just change, instead of writing a bunch of print statements, let's just run this a few different times, see what happens. Okay, let's see what happens if we change this to 499. Okay, we should still get 3.0. Okay, we do. What happens if we change this to a 5? We should get 4 because we're rounding up. So notice that. That's what happens. If we change it to a negative, let's change it to a negative. Down here it says that it should convert it up to the 4. Notice that's what it did, just the same thing as what the positive did. In other words, you can kind of ignore the sign whenever you do the round, and then whatever the sign is, throw that on is what it looks like. Because you get exactly the same values, except that the sign is different. So let's try negative 4,999. Should be negative 3. So as you can see there, so that's what happens. Now, there's other operators here, and I'm going to let you put those into the compiler yourself to see how those work. I don't see any reason why I should do that, but I will introduce each of the functions just so that you understand what they are. So round, it rounds it to the nearest whole number. Seal, for sealing, it rounds it up to the next larger whole number. So if you got 3, it rounds it up to 3. If it's anything over 3, it rounds it up to 4. So it goes always up to the next highest number. But notice with sealing though, the highest number, or the large, it rounds it to up to the larger number. So as you got negative 3 here, it's 3, negative 0.001. It rounds it up to negative 3 because negative 3 is larger than negative 4, and negative 3 is larger than negative 4, so this rounds it up to negative 3. Floor is the same way, well, except it rounds it down to the next lower whole number. So you got floor 3 is 3, floor 3.01 is 3, floor 3.99 is 3. So in other words, really what it's doing, the floor is just ignoring the decimal place here and just going with what's there. Now for the negative though, it's not necessarily doing that. It rounds it down to the lowest number. So negative 3.001 goes down to negative 4, negative 3.339 goes to negative 4. So it's a little bit confusing, but just keep that in mind what it does. So you may want to put some print statements in front of here, like what I did for the round, to see how those what values those go to. Now there's an integer function to where there's sometimes we want to just convert from a decimal or a float to an integer or a double to a float. And so it just takes the integer, it just takes the integer portion of the number and returns it. And so this really does return 3, not 3.0. So let's try that. Since this is a little bit different, let's try that and we can see what it does. So I'm going to copy and paste that over here, get rid of all of this, print that, and print, and this will return the value of 3 as an integer, not as a float. So as you notice, no decimal point, so it just returns 3. And that's what happens with all of these. It just takes a double value, a float, and converts it to the integer portion of it. Converting from one numeric type to another, we already talked about that with integers. For floats, we can do the same thing. One thing to point out here is you have to be careful sometimes with certain values. Like for example, if you try to do an int 8, try to get that value of 128, this returns an error. The reason why is because the range for int 8 is only from negative 128 to positive 127. So this returns an error. This would return, this is okay because negative 128 is within this range. So this, if you understand what this is doing here, then you kind of got you have an understanding between an integer with 8 bits versus other things. So this is a little bit more of an advanced issue or advanced topic that some of you that are new at programming may not understand, but if you're almost at the point to graduate and you've had several programming classes, this should make some sense to you what's going on here. Now, float to integer conversion, what we do here is we're pretty much just taking the decimal place. We're just taking whatever is the integer portion of the number and returning that. So we're taking the integer portion of this and returning an integer. So this won't return negative 2.0. It returns negative 2. Now down here, there's also a float conversion where we can take an integer value and convert it to the float representation of that value. Say a float 1 will return 1.0. So if we go up here, we change this to float, and let's change this to 1, this will return 1.0. Okay, if you put a negative 1 there, it will return negative 1.0. So this will always return a float, a number with a decimal point. Let's see what happens if we give it a float. It should return the same value. Let's see what the compiler does. Okay, it does that. Now the compiler may come back and complain and say, no, this has to be a non-float type. It depends on the compiler, but this one right now, the compiler we're using seems to be okay with that. So you can use different values here. Let's say negative 128, it'll return negative 128.0. Let's give it a minute. Let me try running it again. Okay, so play around with some different values and try to predict what it's going to print out to see if you understand what's going on. Okay, and that's about it for this lecture. If you need to, go over the notes a couple different times so that way you get an idea if you really understand what this stuff means. If you have questions, let me know. If something isn't clear, let me know. I can try to create more examples or whatever needs to happen to help you understand. So thank you for watching this video.